As we continue in Chapter 8, which is giving us all kinds of techniques to help with integration, in the section 8.5, we're going to look at integration using partial fractions. And partial fractions are a way to express a rational function as the sum and or difference of simpler fractions. And usually those simpler fractions, well, not usually, pretty much always, they're going to be easier to integrate. We're going to use a lot of natural logs when we do the integration with these. But there's a couple points that you need to kind of keep in mind. Before starting the process of creating partial fractions, you need to make sure that the degree of the numerator is less than the degree of the denominator. So occasionally you might have to do some long division. And then we need to be able to factor the denominator. Ideally, we want to factor it into linear factors, but sometimes we will end up with some quadratic factors that are just irreducible. We cannot turn them into linear factors, and I will go through an example showing you what we do in that case. As we work through the examples, I'm going to be following the method that's set out here. I don't want to take the time in the video to read through this because you can do that on your own, but you'll see as we go through the examples that I will be following a very clear method for solving these. It's going to use a lot of algebra, in some ways solving systems of equations, but I'll show you some shortcuts as well. So for the first example here, we're not going to actually go through the full process of integrating. I'm just going to show you how we turn a rational function into partial fractions. In this case, we're given 5x minus 13 over x minus 3 times x minus 2. So the denominator is already factored for us, and it is factored as two linear factors. So what you want to do then is set up two extra fractions. The first fraction will have x minus 3 as its denominator, and then the second fraction will have x minus 2 as its denominator. So you could say that 5x minus 3 over x minus 3 times x minus 2 equals a over x minus 3 plus b over x minus 2. And then, of course, the secret is finding a and b. So if we were to tackle a problem similar to this in an algebra class, we would say, well, let's first get rid of the denominators. Well, how do we do that? Multiply everything by the common denominator. So if you were to take that common denominator, x minus 3 times x minus 2, and multiply it throughout this entire equation, you would be left with 5x minus 13 equals a times x minus 2 plus b times x minus 3. And then we can solve for a and b. And there is a couple ways that you can go about doing this. One way that you can go about finding your a and b is by setting up systems of equations. I could rewrite this and say 5x minus 13 equals ax minus 2a plus bx minus 3b. And then I could sort out my terms that have an x and the terms that don't have an x. So I could say 5 equals a plus b. Those are my terms with x's. And then negative 13 is going to equal negative 2a minus 3b. And at this point, we have two equations and two unknowns, so we can go ahead and solve. If I were to take that top equation and multiply everything by 2, I can come down here with it, I would have 10 equals 2a plus 2b. And if I add my two equations together now, I get negative 3 is equal to negative b. And that tells me that b equals 3. Going back up here, 5 equals a plus b. Well, if b is 3, 5 equals a plus 3, so that means a is 2. So instead of having this rational function 5x minus 13 over x minus 3 times x minus 2, I can break it down into these two partial fractions. Now we know what a and b equals, so it's going to be 2 over x minus 3 plus 3 over x minus 2. That one is a 2. And again, this is just setting up the partial fraction, so this is going to be part of most of our examples I'm going to work. If this were an integration problem, we would then integrate those partial fractions, which, as I mentioned before, in a lot of the cases are going to involve natural logarithms. But we'll get to that in a moment.